Hello, welcome. My name's Kevin Piccone and I'm the developer of PlayBASIC. I wanted to take you behind the scenes and have a bit of a poke at my own code. Today we're going to have a look at the code from the Thesius XIII demo, which was written back in 2007. I'll turn the sound off. As you can see, it's 2.5D sort of thing, some perspective effects, transparency or translucency, alpha channel rotation, pixel perfect collisions, that kind of stuff. Sort of demonstrates a whole bunch of things in one demo. As a demo, it's actually way too complicated. For those people who are interested, Thesius XIII, the name comes from a bit of a joke amongst me and my friends about wanting to produce a sequel to Thesius XII, which is a game I wrote back in the 90s for the Amiga, which is a right to left scrolling shoot 'em up. That was written by myself, Ben Hemming, Lars Jensen, other people around the city I live in as well. Lots of people were hands-on with that project. Okay, so getting back to why we're here, let's do a code review of the demo code that comes with PlayBASIC. That game comes with PlayBASIC, by the way. If you download the Learning Edition, depending on what version of Windows you've got, it will install the projects file, but you might not be able to find them where you expect. It's very annoying. If you don't find them where you expect, you can go to the website and download the project pack by yourself, and this is in the games folder. I've already done this, of course. I'm going to jump across. Now I'm using a different version of PlayBASIC. It's referred to as Forest Blast. It was made during a shoot 'em up. They were having a game making competition at the time. This was made back in 2007. That was mostly focused on just making shoot 'em up games. This page through the code, we'll see we've got a whole bunch of different source files. Generally, I've mapped it out into what I would call libraries. So we've got declarations at the very left, which would be in the code terms as it's being built. It gets built from left source to right. So the main's actually at the bottom of the code, and all of the other code sitting above it. So you can see everything above it, what's pre-declared, etc. We've instantly got some stuff in here that's kind of confusing to newbies straight away. We've got an inclusion of an extension to the shape command set, which is the shape library. These add things like loading of shapes, that kind of stuff. We wanted to keep those things external in case the formats change, and we could change subtly in the libraries as opposed to re-updating the whole project all the time. That's the logic behind doing that. In this game here, we've got a few constants that denote debug all sprite collisions. So you must be able to just turn debug for all sprites on. I think it just draws like a rectangle around the sprite so we can see what parts are overlapping. A lot of type declarations, that's the game clock in there. As you can see, this is not a very easy piece of code for someone to actually jump into for their first thing they've ever seen in their entire life and try and dissect. And we haven't even looked at Ali either yet. What I will do is I'll try and run it in debug mode. I don't think it compiles out of the box with this version. No, it doesn't. With different revisions of PB, there are slight differences of syntax. So copy memory is changed, as you can see. Just hit F7 again to do a recompile and debug. Okay, pops up there as well. Doesn't like the parentheses around, or the brackets around those. It's treating copy memory as if it's a command that doesn't return anything, so it's going, why why you're feeding me brackets. Slight differences. Let's try and compile it. Alright, we're running in debug. Now I'm running in debug for one real reason, and that's I'm capturing the screen as well, and I know that if I let this run in full screen exclusive mode, I won't be able to capture it, so I'll have to do that all the time. In fact, I might go set the screen mode to run in a windowed mode up front to ensure we don't have problems capturing the display. The debug is quite simple. We've got a variable overview, shows the main scope, and each scope there has its own variables and structures inside them. And it's a big program, so there's a lot of stuff to look through. Our console is just for dumping out the hash print statement. If I hover over the window, click the mouse, we can play the game. It's being slowed down a bit because of a bunch of text being reported. Now it's halted. Obviously that's debug output. Hit continue to keep going. We might remove that for our video's sake. So here, if I click the right hand mouse, we just render some test explosions for some reason. I know if I press the function keys, oh there's one, F1, it generates a bunch of those spinning. We just died. It's pretty hard to play apparently. Oh, it's gonna hit break every time. Yeah, it's spawning all of those things there. We don't really want to do that. Oh, dude. Difficult. Yeah, it's pretty hard to play. Alright, we'll get rid of that break. Do a search for break. Actually, on the project startup too, on screen, let's go into full screen. We'll go to window mode. Okay. Do a search through the whole project actually. Finding project, open the screen. Good. That means it's just setting the default screen size through the project, and we're not doing this anywhere else, so it's okay. So if I run it normally now, just in normal compile and run mode, one of the reasons I wanted to try this out was actually I was kind of sick and tired of sort of digital input, you know, so you're using like the arrow keys or ASD keys or whatever, or the controller, etc. I thought maybe it might be fun to have a mouse control. Why not, you know? Whoops. Pretty hard to get that to go. We do a search for the break function. If we define in project, that's what's stopping the debugger. I found one of them. It's in the world manager, which makes sense because when that's where it's loading that world data. Now I know that because I remember that from looking at this, but no one else would be able to even remotely dissect what's going on in this program. Just do a quick save. Head back to the main. Wow, this is actually the main loop of the program. So the title screen and this run within a loop, and we've got this game state variable created somewhere else. I guess it's up in declarations. So our game state will be up in here somewhere. It's just a type, just an individual type that we're using really to give ourselves, like, if you want to have global variables in your program, you can just set the variable to be declared as global. That's fine. But there's a chance you might have a collision with particularly simple variables, particularly like that. If you had a variable called LP, which might be short for, you know, for something that you're aware of at the time, and then later on, you know, your friend writes a bit of code for you and uses LP as a loop counter somewhere else, and you don't notice that odd bit of code, you plug it into your program and weird behavior starts to happen, you know, because that loop was, or that function you're plugging in happens to use something that's declared globally somewhere else, is now that variable is affecting the global state rather than the local state within a function. That making sense? Yeah. Anyway, so the whole game, from what I can tell anyway, we've got this type structure here which represents the state of the game, state changed timer. So obviously when you click the button and you're transitioning from one screen to the next, there's a countdown until that happens so it can fade the screen out. What the current player is. Obviously it keeps track of some basic stats as you're playing, you know, things like probably how many things you've shot or something like that. Where's the stats declared? Game clock, active player bullets there, active particles, so we can kind of keep track of how these things were spawned, created, give ourselves an idea of what the balance, like it might be nice to have like the average frames per second stored in here, or I mean, who knows? But I think that's kind of beyond the scope of this particular demo. This demo is written as a game first, not as a set of libraries to go use. I think some of the coding is probably reusable, but a lot of it's just written around this one idea. Like this image library here, that's reusable, but the rest of it's generally written it's a one-trick pony. It's been written to be used in this case and this case only. So declarations. So we've got a whole bunch of global information stored inside this type. Now we can only get access to those things by going game dot whatever the sub. In this case, we're talking about the clock there. Game dot, you know, it would be game dot stats or game current player or something like that. And that gives us some protection against simple typos in our program. Like, you know, you might have maybe you've got two players in your game, or whatever. You might think of game, you know, current player as a global somewhere, and it might be player one. There might be an array of players somewhere else, right? Now it's very easy to make a typo. Maybe down here we're going, you know, print score from, sorry, print score, and we might go players, current player dot score. So we might have an array of players, and this has a field called score in it, obviously. But this variable here, if I make a typo and I'm typing this out rather than cutting and pasting it, I miss the M key and hit the N key, nothing will trap that. So we won't know this is broken until this bit of code's executed. You can catch those things by going explicit true. That now means you've got to explicitly declare every variable you come across. Sometimes that's convenient, sometimes it's not. You'll notice that in some libraries I write, I use explicit, other times I don't. I just can't be bothered. Sometimes it's useful, sometimes it's not. So you can turn it on there, turn it off. And it will only affect these couple of lines inside here. And this wouldn't compile because players doesn't exist or anything like that, but hopefully you see my point. Whereas if we use this concept up here, this wouldn't compile period because this is undeclared. It's the same as having our explicit mode turned on. Alright, so we've got our game clock set to quad frame rate of 50, number of ticks per frame, which is going to be 20 milliseconds in theory. We've got a location of our standard folders. So what I'm expecting to see is that the game itself doesn't refer to these internally ever. It just uses these. And the reason for that is we never want to have to go and edit something in a library or somewhere else that has an explicit or an absolute string or those things. If we can avoid it, if we can just avoid that issue by putting this function, as simple as that might be, somewhere in the main where we can just call it, and we're always guaranteed when we call that particular piece of code, we get this same response out of it every time. So if we ever change the location of a file, when we hit recompile, everything is looking at that new location. Here we're not using a function, we're just storing this in inside of our game, our game sort of state really. Could be a function. You wouldn't have to store it in here. You might store the running the current directory of your executable, and then you might have a function that get I don't know, music folder or something like that. So inside here it might go, if this existed, game.current dir. We're going to add on, what was I saying? Music. And that achieves the same end really. We get protection from ourselves by making modifications. If I ever modify this, and it only ever occurs in the program once, I don't have to worry about any successive changes. Environment quality. I have no idea what that's meant to mean. That's what I mean about this being, it's way too complicated for an example. This is the object structure of, I would say, the aliens in the world. They've each got a status. In other words, is it active or is it dead? Position in 3D space. An old position in 3D space for some reason. So I think some things there are probably using polar coordinates for their movement based on these acceleration steps, these things here, angle, speed. So you can probably set a different mode for what kind of control you want the alien to have, and then set an angle and a speed, or maybe there's different acceleration types. I mean, who knows? It's not documented. I mean, who knows how this works, meant to work. There's a right handle for secondary complexity for the animation of the current frame. Suspended delay. There's a lot of stuff going on. Okay, this sprite has an image of its own, because it may or may not need to be rendered to and then destroyed. Game clock there. We haven't even got anywhere near the game yet, so let's pick through the other code very quickly. Building fonts, yeah, okay. It's making this the bitmap font we see in the opening screen. Yeah, very simple font here. Alright, hit escape out of that. So this is doing some sort of mapping. A lot of bitmap fonts and character sets they only include certain parts of the character set, so they don't include every symbol. So here, obviously the font I've picked, this is the order in which the symbols appear. It's mapping out into the ASCII. So the font's not stored as in ASCII order. That's all I'm saying. Load bitmap fonts. Have a look at this function. I'll include fonts. There you go. Another internal library that's being used that most people wouldn't be aware of. This has been updated, by the way. This wouldn't have been there in the original version. We're checking what version of PlayBASIC it is. If it's below that version, we're saying you need this version here or higher, and then aborting compilation. We're here, we're checking the debug mode, the build process. Is the person compiling the program in debug mode? If that's true, check what debug mode it is. We create a constant to preserve this state, so we want to set trace mode back on later. Trace mode's for having the runtime and the debugger coincide each line by line. So here I'm saying turn trace mode off. So even if you ran this in trace mode, it would not trace through these functions. There's no point. You want to trace your code, not sub-system sort of code. So have a look at this thing. Okay, what the hell's happening? Format parameter 2, video compressed raster font. We're defaulting to format 2, which would be a video font. Checking if this file exists. It's good so far. What happens if it doesn't exist? Nothing special, apparently. Generally, it's a good idea to give some warning, something's happening, So, if you're really writing this for your own sanity and production code, if we went to, if file exists equals false, we could go failed, file doesn't exist. Maybe you put the file name in the middle of that or something like that. Right, and then we would exit function here. We can also get rid of one of the nests like that too, really. We have a comparison up front, checking for, does this thing exist? If it doesn't, we instantly bounce out of the function back to where the caller came from. And I would generally recommend having some sort of debug output. So you can look at your debug console, or whether you're outputting to a file or whatever you're doing, and see, okay, that file name's wrong, or the location it's looking in is wrong. So the way it's set up at the moment, if you gave it the wrong file name, you wouldn't even notice. There'd be no warning it didn't load properly. Back to where we go. We are preserving the current surface, which is a good approach. We're looking at the format and then creating a font based on these two things, that's interesting. We're just creating an AFX font regardless. Not sure that's the best strategy there. Okay. So if this font exists, another potential here for where it may not have existed. We change rendering to our newly loaded image. Oh, sorry, we're not loading a font, we're loading the image. So I'm wanting to load the image with AFX regardless. So really that could just be, I don't really see any point of doing that the way it's set up there. Except here we're being very deliberate about the format. You have to recheck that really. This is the kind of thing where if you went and made an off-the-cuff edit, you could generally rerun the program. Maybe the program works perfectly, but then other bits of code that use this function may now break because I've inadvertently altered the logic of how this works internally. One thing we haven't done here too is we haven't actually got, we haven't told PB to be explicit with variables. Generally, that's what I prefer to do in libraries. I would preserve the explicit state, enable explicit to be on for this section, and then have every variable in here that's used inside here. This would be a local, right? Format was passed in, wasn't it? So we don't need to, yeah, format's passed in. Temp image is not though, so that would need to be declared. Otherwise, there's a chance if you're using temp image somewhere else in your program, that variable, and it's declared as global, now you have a collision. And you'll never know this. There's no warning from the compiler. It just assumes that you are up to date with this stuff. One way you can detect these things is hitting compile and then finding this function and then looking at the locals. And if it was not declared locally, if it was declared as global, it'll tell you. Alright, we load the thing into memory, yeah. We're checking if it exists. Now it's possible for this to fail. You might have chosen an image format that the internal loader can't load. So that's why it's being somewhat pessimistic about the whole thing. It's going, did you actually load this thing? And if you did, okay, now we can start redirecting all drawing to that freshly loaded image. We'll assume that's the mask color in the top left-hand corner coordinate, and start grabbing characters from it in the order which we set up front. Once we're done, we delete that temp image, restore rendering back to where we were, convert. Okay, so if we need this to be converted to or CRF font, we can do this by setting it to format 8, and we'll do this internally for us. Yeah, you know, kind of typical sort of code really. Probably needs a bit more safety code in that to be more comfortable. Wow, it's just the fonts. It's a lot of stuff. So this is way too big an example for it to be included with PB up front. Got the screen properties here. This is to do with the depth. It's computing the... Oh wow, so we've got screen has a default color, which must be like the CLS color or a backdrop image, I'm assuming. Width and height. Now the screen's actually larger than what the PB screen is. That's what lets us do that kind of scrolling effect up and down. We're doing a projection there of the scene. We're also doing a scan line by scan line ripple effect on the water at the bottom, or the swamp at the bottom. Probably didn't notice it. Let's run this thing down the bottom here. Look carefully. There you go. See how it's rippling? Probably should have had like a splash effect for when things come up out of the water and some of that. Get the idea. So there's a whole bunch of effects taking place. Too much of the stuff is taking place. It's like camera shake in there. Shake size, shake angle. I think it's just doing I don't know what that's doing. Probably setting the angle and the radius, and then probably dropping the shake size down. So it's probably randomly choosing an angle each frame and then stepping between it, that kind of thing. I don't know. Projection of the screen, undocumented. We are doing a depth projection of the scene, and we're doing this manually. Clipping to the play area, which is this artificial area where the game's taking place, and then it's being projected to the screen. animations. What have we got in here? We're storing images as uncompressed, raw, pre-cropped frames. If you want to get the best compression, it's actually not a good idea to store everything as PNGs. PNG uses the deflate algorithm for its compression. When the deflate algorithm tries to compress data that's been previously compressed with deflate, those chunks of data end up larger than what they were when they started out. So you can actually, by bundling up a bunch of PNGs in your file, you can add another 10% to the file size. Normally it's compensated because other files compress much better. But one way you can get around that is actually doing a bit of light compression yourself on the data. Our internal CRF format does a much better job than what this does. This raw image routine here does, but the principle is much the same. I don't even remember what this does now. I think it just runs through a bunch of images and makes a pack file pretty much of all the frames, storing its original width, its trimmed size, so it cuts off any dead pixels around the outside of it, any transparent pixels that don't have any impact on the image. And that's how it recreates the original image from the parts that have pixels and now, rather than just storing the whole frame. The net result is that it compresses much better. And actually loads quite well as well. You can load the stuff straight into memory. This is the loading for it. That's it. So we're calling a bit of highly optimized code to pull this stuff off the device as fast as possible. We're not sitting there in a very slow interpreted loop through the runtime going, give me an integer, give me another integer for every pixel. No. Let's just load the whole block as fast as you can load for me. Thanks. And we're just converting it across. Given when this is written, this is probably, I think it's just doing a bunch of dot plots or points. Yeah, it's doing dot plots to actually create the image at the end. That's not needed. You can use copy memory to a row, because the buffers are 32-bit. You can have one row that's of whatever the required width of this target and this output image is going to be, and copy the pixels in, just use with copy memory, and then use draw image to draw that row. Now the benefit of doing that is that you're passing the required, here we're doing, this is a 100 by 100 frame, it's 10,000 iterations, it's 10,000 dot plots and 10,000 peaks and 10,000 additions. We could break that down to really a copy memory, or 100 copy memories and 100 draw images to draw the strips. And that's going to be a lot quicker than what that loop's going to be. But, still, it doesn't work for these palette map ones, but we have a palette mapped library in PB these days that can do exactly the same thing. We didn't have that when this was made. This is an extension library. It's not even an extension library, it's just a bit of library that I gave away to people who wanted to check it out. But in terms of complexity, way too complicated. This animation file actually generates animations as well, which is, here we go. So some of these other animations are created inside the program. Yeah, what's load raw animation? Where does that even exist? It's definitely inside raw image, isn't it? Yeah. It's easy to tell why people don't bother trying to understand this program. It's just too complicated. Raw animation. Yeah, we're just opening the file and calling this another wrapped function from here, which must load an animation from an existing file handle. Got our frames of raw frame, we pull them off the disk, we read memory as quickly as what we possibly can. It's a lot of work, isn't it? Alright, that's our animations. We're loading the animations of the various ships and items in the demo. We've got a library that's called Path, which has had these copy memory problems with it before. This is what the characters were doing, following their movement. If we play the game again, boom, alright. So that movement path there is obviously a bunch of these, a plotted path where each ship is following the same path, but they're done at different time intervals. Whoa. Whoa. Hey, it's too much. Definitely plays too hard. A lot like Thesius XII, it plays way too hard. There was a key to actually add, well there it is, add more bullets. That's better. They're all separate bullets as well. So now it's kind of actually playable. Shoot that thing there. I think I've got homing missiles and those things. I think. The artwork, I have no idea where most of this artwork came. Some of it came from Pinko Paxton on the Dark Basic forums. Other bits and pieces, I think the backdrop was by Blink. The ship, I think it was Pinko's as well. I don't recall now. The ones on the ground were made by Laz. Another Dark Basic programmer back in the day. Probably 20 years ago now. Okay, so hopefully you've seen the pathing. That's what that library's all about creating. What we're doing here is we've got an array of these movement paths, and each one has a name. So I can refer to the path by name in the external file. I don't have to have path 10, path 15 or whatever. I can give each one a name. You know, this is a spinning crawler thing doing a S-band or whatever it was going to be. And I can refer to that in the creation file. I never have to know where it is in memory or what index it's going to be, and I don't have a magic number at any point. But to do that, it's a bit awkward. You've got to have these names, then search for things by name and find them and stuff. That's why we're storing the name as it was declared, the name in lowercase when we need to search for it, the number of vertices that this path has. The path itself is just a list of these vertices starting from, and we traverse the path going from vertex 0 all the way through to the end of the list, the array actually. We've got a size of this secondary buffer which stores the vertex data, and that's the buffer handle there. How it's implemented in this one, I don't know. So we're just checking a valid path index, yeah. New movement path. Way too complicated there. New movement path and string. Count bits in coordinate mask. Okay. I don't know what that's used for. I have no idea what that's using that for. Coordinate mask, what does it need that for? Checking the number of this array. What on earth is that doing? So we're taking a list of these. They must be delimited. Just a bunch of values delimited with a comma between them. So probably each pair would be the vertices. These aren't absolute locations. They're just. So initially, the first vertex is going to be 0, 0. So we're starting from whatever location we're currently positioned at, and the path is the offset from that location. So we're checking how many tokens were found, coordinate mask. Wow, that's complicated. Size, movement, path, bits in there. Because they're stored in banks. Okay. See, all of that data could just be stored. It could just be stored in one big blob of bank data. That's perfectly fine. And then we just have a pointer to where the start and end coordinates are. That's probably easier than doing what we're doing here, but maybe that was awkward at the time. Copy memory to scroll there. So we're doing an insertion there of some type or a deletion. Delete a point out of the buffer. Insert. Wow. Just find closest point. Wow, there's so much stuff. Alright, we haven't got to the player yet. The player is set up here. A pretty typical sort of structure. We've got our player array, and each player is the same type here. So the theory was to have multiple players. Got some angles to do with our tilting, speed this frame, bullet count, invincible. Wow, directional, homer. Oh, it's types of objects we can create. A directional bullet or homing element which would be shot out from the player and then targeted onto a particular character, or maybe it only would home on bosses or that kind of thing. You never know. Player vertex, blast, smoke, max. I don't know what any of that is doing. This is the problem, it's indecipherable. Right, we're building our player sprite. Normally I would put this into a function somewhere else, but given that this is happening inside this thing here once, probably not necessary. Free all players, delete them all, destroy player, release everything that's associated with it, find the closest player. Obviously that's for doing things like homing on the player or whatever. Let's check out the aliens, probably much the same really. A bunch of different constant types. So we're enumerating these out, going, this is the outrigger, the crab, the spawner of the crab. So there must be some object that is laid out in the world space that actually generates those crabs. So there's no internal bit of code that randomly creates crabs. It's part of the level. Static mine spawner, bunker, generic animated. In other words, this has no specific controller whatsoever. It's just a general animated character following a path. So it could be just anything. Homing missiles launched. Just wow. Update aliens. Let's have a look. So grabbing the player's position, the current game player, because we're going to need to target the player throughout this frame. Okay, our screen height position, gameplay area, suspended delay. In other words, is the character being, is it even being rendered yet? If it is, we wait until the number of frames have passed. Current position. We've got a class select case for the kind of animation we need for each one. So we end up with a giant select case, which is quite common in these kind of things, really. I'm not a massive fan of these kind of nested behaviors, but I don't, if I have to do it, I do it regardless, you know. Because what you end up with is, once things grow, is that the controller code is enormous, and finding a way around it is just a massive pain in the backside. At the time, I don't think we had call functions, so you couldn't just call out to a function of this particular character type and then pass it what you needed to. Which, you know, look, it's slower. There's a bit of overhead by calling a function, etc. But you don't have this giant blob of code that does everything in one giant loop. That's all I'm saying. Move only along path. So that's a wrapper function over the path controls to have something follow a particular path. Launch a convoy. I don't know how any of this relates to anything else. So when we hit something and destroy it, we're generating fragments of something's exploding when we're doing that. Oh, it's crazy. Outrigger, particles. Update particles. These are all sprites within the scene, I guess. Sprite image, yeah. Animations are stored inside arrays. A typed array too, by the looks of that. Particles array handle. Yeah. Way too complicated. World manager, what does that even do? Oh, this is loading the world file. I'll go find that file for us, actually. Alright, so if we look at that world file, look at the number of sources that are in this project. Levels. So I think the idea was to have the game be a definition of, which would just be an array of what levels are being played next. Yeah, so it's kind of like markup, where I'm using these tags I'm skimming down, looking for this particular tag, and then going, okay, stuff inside here is related to whatever this here is going to be. This is general information. Okay, player spawn position, so that must be where the player starts in screen space. Player mouse position must need to set that for some reason. We've got a bunch of media we're loading through here, which is how it knows how many things it needs to load up front. That's how it computes that. So it gets a list of all the files it's going to load and then runs through and just loads those in chronological order. It doesn't do a bunch of load image type stuff. It has a list of the files we need to load. We go through and do it. I don't know what these properties here mean. I suspect that's something to do with the draw mode, but it's not documented. Oh, there you go, it's map levels. So in other words, when that image is drawn or loaded, we want to create 3 different versions of this that are smaller than the load size. That way, when we draw a version of the image that's scaled down a lot, we can use a much smaller version of the image to start with, which is easier for people to render. Environment, this is a trigger list really, so this is the background. So we've got, this is what our parameters mean. This is the name of the image, which we're using from up here. We're not using any indexes. I've just called this image building 1. So when this Fraser looks through here and sees image, it's going to search for this in the environment list to find the index of this particular character. That way we're completely separate from the index system entirely. I can give this to, in theory, you could give this to someone who's designing the level and they could conjure this up themselves. The rest is pretty impenetrable, really. A bunch of information there that would be better suited to being produced by a simple drag and drop editor than doing it by hand. But for this demo, that's how it was done. I was just dropping these things in. So it's location in game space. You'd almost be better to have these with like environmental flags, like map coordinates kind of thing. So you don't end up with these massive values. Not that it matters, I guess. Wow, there's a whole bunch of... I think I generated the standard environment stuff randomly. Yeah, just went through and generated a bunch of that stuff, slapped it all together and went, that'll do. See how they must be sorted internally as to which... Yeah. Got some happening at -1000, way back. So that environment loading library that must manage that stuff for us. This is the paths, as I was saying before, they're given a name. I don't know what this binary value here is doing, I have no idea. And there's a whole bunch of vertice offsets from vertex 0 through to the end. Then swoop 2. Rush. So I'm assuming that characters will use those. Let's have a look. We've got trigger event types. I've bothered to comment this for us. Not that I understand what it is today. I've tried to simplify these down. So we've got just, hey, we've got a position where it gets triggered, and then it's location where it gets triggered. In other words, as the camera is scrolling across some world space, the object doesn't get initialized into the main game scene until we reach that position, this trigger position. And then when it gets triggered, it can start to be on screen from, maybe it wants to start behind the character or to the left of the character, to the right, above, below. So that's why it needs a position as well as the trigger position. The crab stuff we were saying before. Alright, so we've got trigger equals 1000, which there, outrigger, there you go. So outrigger is that that spinning character. It's got a trigger position, whatever that is, I don't know what that would be, outrigger. X position. Oh, that's a constant that's going to phrase out from here. In other words, because we may not know the top bound, the upper bound or the lower bound of the game world, we have some constants that we can phrase out and let the phraser do the work for us and let the designer design, That's the theory anyway. That's about it. So this generic animation path here, it's occurring at, being triggered at offset 2000. We're using the viewport top minus 150 pixels. So above the top of the screen, 150 pixels above that point for where it's been created initially. That's it. So you never pan up and see this thing just magically appear. It has to be outside of the clipping area. Then swooping down, wherever this swoop hook 1 is, which is probably, coming down the screen, hooking back up here or something like that. Wow. It does show, look, it's not a great way of separating the game data from the world data, granted, but this is one way of doing it, generally you want to have simple is better, I would say. The less data you have to provide the characters with, the better. In the real world, what you would do is you make a little placement editor, so you could load the scene in, have it load the media, and then run through it and just position the character types, position and plot out the path you want to assign to this particular group of characters, and that would be the end of that. I'm assuming that these here are some sort of group. I don't really know. Too complicated. Way too complicated, to be honest. For what is a straight demo. So we've got to the main loop, which is showing the title screen initially. So look at that code for a second. Find declaration. We're setting game state to title screen. In other words, we're in a loop until this is no longer title screen. So we've pressed a key to exit title screen, or maybe we've hit escape to exit. We're checking the timer and then seeing if the amount of time has elapsed before it's time to redraw the screen. We're doing it manually in this particular case. So what this does, it means our logic and rendering are separate from each other. What that means is that if we're running on a computer that can't render the screen fast enough, it will step characters forward for us. So effectively we're skipping the rendering of some frames in favour of keeping the speed of characters pretty much the same. So you end up with motion that's not as smooth, but the gameplay is much the same. So even if it's rendering, at half the speed, it'll look much jerkier, okay, but you won't have a situation where characters will skip over other characters when you just try and move forward by a random multiplier of their current speed. Redraw is just doing a screen redraw of the display. Back to play game. So we're doing what? We're forcing it to load this game level. Now, ideally, what I think was happening, what the idea was for initially, is you would load from the game text file and look for level 1, and grab this file here, then load that level. So you can just have a list of these files, and that could be created, or you could skip between levels just however you wanted to, It's challenging, but it's not that challenging. Loading the game media, seeing our initial mouse position. From here on in, we've got a bunch of hard-coded stuff that is redrawing the frame. Same logic. We're checking the game clock to see how much time has elapsed. If the frame is running short, in other words, the computer's running really quickly, we don't bother updating the logic and redrawing until enough time has elapsed. We probably should actually have a pause in there to give, so a system that can run the game very easily can give that time back to the system. Now you might have some the byproduct of that is you might end up with a bit of bouncy frame rate, because you know other applications will be chewing up time from your game running, but it can be better for the end user. So redraw the game and update the game. Let's have a look at update the game. So if we're fading in, okay, updating the aliens, doing the water waving stuff if we need to, moving the alien bullets, moving the players, moving this stuff, updating particles, doing our test stuff with toggle trader. Oh, that's nice to know. Didn't know there's a trader key in there. Key state 20, probably the T key, I guess. Function 3, what is that doing? Oh, it just generates something. A bunch of swooping aliens, I think. 5, the game scroll speed. Bump player bullet count, okay. Function 8. Let's try some of those. Just trying T for trainer, let's see if that works. No, it doesn't. How rude. F2. I generate that thing there. I don't know what that's doing. Whoops. F5, F6. Don't know. Oh, F8's the board count. Getting lots of boards? Yeah. That's funny. Just say the. Oh, there you go. So the miner's checking to see its vicinity away from the player. If you're close to the player, then we'll spin a bit faster. So probably should have. I think the theory was to make them explode or something like that. Well, get away. It's impossible to play this game. I mean, calling it a game is a bit of a stretch, really. A lot of stuff going on in it. And it really is, it's just too complicated. As an example of the come with PlayBASIC, it's too complicated. None of the code that's in here is all that reusable, and the lessons you have to spend deciphering this example to get anything out of this. Oh, it's the end of the demo. Oh, there you go. It's the end of the mission. Good for me. Back to the start. Oh, spacecraft is just testing a bunch of homing missiles on the blower. Alright, this has been a nightmare going through this program, and. and understandably it's a nightmare for other people to look at. So I'm not too sure we'll keep this one in the example pack. Wow, so the screen redrawing is interesting too. We're doing a captured scene. So we're using a camera to render the 2D elements in order. And at the end of that process, let's try and think what happens here. We're drawing all the sprites, we're drawing the camera somewhere to an image off screen. We're restoring the image draw modes. I think it's necessary to compensate in order for when characters are hit and they need, if you're skipping over what frames, you want to make sure the player sees the impact of their bullets on the opposing characters, then you can't just have them flashed and not be drawn. So it has to be, if anything is flashed or hit or those things there, we have to wait until the character is next drawn to make sure that there's some visual response or visual feedback to the player. Hide environment. Wow, what's that stuff doing? Render water cross-section view. Draw player score, render screen. Sign copy image to screen. Okay, we just cut that out there. Yeah, there you go. The whole screen's copied across, so we can't see anything. So look at the function. Right. I think we're drawing the top section as a block, and then we're drawing the rest of the parts as we're copying the rectangles across by 1 pixel at a time, or maybe whatever the span step is here. I think it's maybe a few pixels. There is. Set that to 1. So the sine wave at the bottom. Whoa, brutally killed that time. What if we set it to spans of 10? So the waving would be a lot less noticeable now. Yeah, much smaller. Get away. I don't mind the idea of having the control by the mouse actually. It's much easier to play. You can just sit down and go for it. I mean, it's weird. It feels a bit weird, I guess, but much more like the analog sticks of back in the Apple II days. 4, wasn't it? Whatever that was. I don't know. We'll times that by 50. We'll see what happens. We'll make a real mess of it. As you can see, a real mess of it. This is the problem with this example in general, is that it's rigidly written to do one thing and one thing only. A lot of a lot of the functions and these libraries that are part of it are all interlinked. It would be very difficult for someone to come through this and pick out a bit of code and use that in their example as in their game for a base. Which is the problem with these big examples. They're very hard for people to follow, they're not documented very well. Yeah, it's a challenge. But they're all we've got. Anyway, I've been talking for an hour about this thing. So that's Thesius XIII. Hopefully you learned something about why it exists and where the idea came from. And our overview is pretty simple. Code's not great. Could do with a bit of cleaning up, I guess. But my gut feeling is that would make it even more complicated for people to understand. There's some good practices in this, like this model here is quite a good idea actually. It does do things like handle alternate frame rates, it has a bunch of special effects in it. It does thinks about compression of images, has pathing systems, has a way of storing your levels that's not built into the game, which is really terrifying when people do that stuff. But it's just too complicated for people. Not much of a game either. So I think some of the other examples are more effective and they're simpler. We're probably pushing about 7,000 lines. And it's way beyond what most people could actually comprehend. Oh, I've got a debug mode. There it is there. On screen during gameplay. So let's have a look. I hit enter. There it is there. That's cool. Hey. Yay. Yeah, that's pretty handy. Make it easier for yourself when you're writing your application. Yeah, the footprint of the code's too big. It's not documented well enough that it would need to be. You need to have every little facet of this program sort of documented to make this make sense to people, I think. It does have some stuff in there that's redeeming. If you want to dig through it, then be my guest. But it's going to be a pretty hard uphill battle for most people, I would say. Thanks for watching, and hope you learned something. Hope you weren't too terrified by the size of this thing, and we'll try and write better examples in the future. Bye.